Hello everybody, Root Beer here. We're back with the 2000 Fermat paper, and we're on to question number 19. Alright, so what does 19 have to say? An ant walks inside a 18 centimeter by 150 centimeter rectangle. The ant's path follows straight lines, which always make the angles of 45 degrees to the sides of the rectangle. Okay. The ant starts from some point, we'll call it X, on one of the shorter sides, so one of the 18 centimeter sides. The first time the ant reaches the opposite side, so the other 18 centimeter side, it arrives at the midpoint, so 9 centimeters from either side. What is the distance, in centimeters, from X to the nearest corner of the rectangle? Okay. So maybe we should start off by drawing our picture. And instead of having the ant start at X, how about we have the ant sort of walk backwards and trace his steps or reverse time. So he starts at some point X over here. And we know we have 150 and 150. And in here is 18 and 18. And we know he ends up, we're going to use green for the ant. We know he ends up here. It's sort of a distance 9. Okay. Well, how did the ant get here? Well, there was that 9 in. So the ant walked, he didn't obviously walk from the X. He sort of starts off and he bounces back and forth. And he always meets at an angle of 45 degrees. He always walks at 45 degrees to the side of the rectangle. So to get to this height of 9, he must have been walking and just sort of continues on like that. So he must have been walking, and each of these angles is going to be 45 degrees. Okay. But the nice thing about 45 degrees inside a rectangle, well, rectangles have right angles. So in fact, these angles of 45 degrees in here mean that whatever distance, however high he went, which is 9, he must have gone that distance across, because it's an isosceles triangle. So we have a distance of 9 here. And how about this one right here? Well, we have a giant triangle right here, but we can break it up into two triangles of height 18, with interior angles of 45, so we're also going to get 45. And so then he'll walk another 18, and another 18, and another 18. Let's get this 150 out of the way. And it'll keep going that, another 18, and another 18, all the way down to some distance, we'll call it y, that he goes until he reaches point X. Just if the ant traces his steps in reverse. Okay, so using this information, we can sort of figure out what's going on. We know that he travels the length 150, and we know when he gets over here, he reaches the midpoint, and this is the first time he's been on this side. So, what we'd like to do is figure out what y is, because y will tell us how high up our point X is. And then we can just see, is it closer to the top corner or the bottom corner? And then from there we can answer the question. Because what we want to know is, how close is it to the nearest corner? It's either going to be the top right corner or the bottom right corner. And whatever y is will help us determine that. So 150, which is the total length, is 9 plus some amount of 18s. I don't know how many 18s, but some amount of 18s. Plus y. Okay? And y, it's going to have to be less than or equal to 18. Otherwise, he'd hit the top and he'd bounce again. And so that would be counted as part of the 18. So y is definitely less than or equal to 18. Okay. So that means that y is equal to 150 minus 9 minus n18. N copies of 18. I don't know how many that is. But I do know that 150 minus 9 is 141. So how many 18s can we fit in 141? Well, 141 divided by 18 is about 7.8 copies of 18. So we'll have 7 of these 18s, and then we'll have just a little bit left over, and that's what y is. So 141 minus 7 times 18, when we work that out, I wanted that to be very clearly a multiplication, not a dot. Turns out we get 15. So y is equal to 15. So if we just sort of zoom in on the end, our ant going backwards, so I have a 15 here, and a 15 here, and this will be an 18 over here. And these are all 45-degree angles. So with a height of this side of 18, the closest he is to the top point, the top right corner, and that's going to be a distance of 3. So 3 centimeters to the nearest corner. And let's figure out, is 3 centimeters one of the answers? What's the distance in centimeters to the nearest corner? 3. So the answer is A. Alright. So in the next video, we're going to take a look at question number 20 on the 2000 Fermat paper. And hopefully I will see you guys then. Thanks for watching.